I will be discussing Newton's 3 laws for billiards. Newton's first law says that an object in motion will stay in motion. The felt forces the ball to slow down. The force of the stick on the cue ball causes motion, also force on the cue ball on the ball. Newton's second law, force equals mass times acceleration. The cue ball mass is constant. The greater the force, the greater the acceleration. Newton's third law says, for every action there is an equal and opposite reaction. The force of the stick on the ball equals the force of the ball on the stick.
Alright, in our project, work is represented by the force of the stick on the cue ball times the distance that the ball travels. The momentum in our project is represented by mass times velocity. The greater the velocity, the greater the momentum of the cue ball. And impulse is represented by the force of the stick on the cue ball times the amount of time that the stick is in contact with the cue ball.
So, in billiards, there's lots of energy. As the player uses the stick to hit the cue ball, the energy is transferred into the system. The energy goes from the stick to the cue ball, then the cue ball starts to move. And then, from the friction of the table, from the forces of the table, the cue ball slides at first, and so some energy is lost there because of heat and other stuff. So we have dis there, but then the energy is into kinetic energy as it goes until it hits the other ball.
Torque and angular quantities. Angular velocity is the quantity that expresses how fast the ball is rotating, using radians per second instead of meters per second. Angular acceleration, this is the rate of change in angular velocity over change in time. This is made in observation of using radians per second. And angular momentum, this is the mass of the particle that's the furthest out being struck times its angular velocity. Striking the ball near the top of the ball will result in a positive torque and a positive rotation, and it will allow the ball to go through the transfer of momentum to the objective ball. Striking a ball in the center of mass will have very little torque and very little rotation, resulting in the ball stopping at the instance of collision. Striking the ball near the base will give it a negative torque or a negative rotation and allow the ball to come back towards the person, the negative direction, after colliding with the objective ball. This is an example of positive torque or positive rotation. As soon as the ball hits, it follows through. This is no rotation, and this is negative rotation. Seen in the example. Positive, none, and negative.
Techno disco. Disco.